Hi and welcome to this quick overview of the Meniscus Analytics platform, or MAP, and it's showing some of the core capability that is built into the underlying MAP platform, which is delivering and being used to deliver this dashboard solution, which is looking at using real-time rainfall data for 60,000 square kilometers of real-time rainfall data, which we're then using to aggregate up into around about 6,000 catchments. Each of those catchments we have a number of calculations to work out the estimated volume of rainfall that will be entering that catchment at any particular time, and this is all part of an objective of delivering a sewerage network management tool for the real-time sewerage network management tool for the whole of a region and the whole of the company's region. So this is just a quick overview. I just want to explore some of the main features of the dashboard, which is used to visualize that underlying data, but all of the processing, all the capability, all the flexibility of the platform is what is being used to deliver this information. So we have 5 main areas. We've got the OpenStreetMap graph or mapping application on the front end. We have the tabular data, so all the data that's been displayed. So this actually is displaying the latest rainfall data that we have, so at 9:10, so it's 9:15 at the moment. So those are the actual rainfall values, and that's its data, so longitude and latitude of each of these pixels. So we are showing pixels on this. This is not a GIF image of this rainfall data. We're actually pixelating each individual square kilometer to grid. Over here we've got the selection criteria, so this is what to show. We can look at grids, multiple regions, we can select single regions and create our own regions. We can look at a range of data for each of those attributes. So when we look at grid, these are the data that we've got for the whole grid, and this will change when we look at regions. We've got some data aggregation methodologies that we can apply to trends of data when we're looking at single regions of data. The alarms isn't actually working at the moment. This will be up and running in the next couple of weeks, and we've got some tools underneath at the bottom. When we're wanting to use dates and times, so when we're looking at historic data and we're wanting to display either date ranges for graphs, or we're wanting to look at grids for a particular moment in time, then we can use this top time bar to select and choose the date ranges, etc. So if I just now go back and look at, we'll change this to rainfall intensity. So now effectively we've gone back and looked at historic data. Now I'm just going to, I know that on the 8th of the 1st, around about this time, it was quite a wet time. So that's gone back and shown the average rainfall, or the rainfall at 1525 on that particular day, and we can use this time bar just to move through that data. So that's going back and getting all the data. This is the actual numbers, etc. underneath here, and we're showing this at 1 kilometer, at 3 kilometer custom grids. So we can choose any of these grids. These are all actually aggregated on the fly on the server. So this is, it aggregates. So we just show 3 because it's quick. If I want to change to 1, I'm going to just zoom in because it doesn't work well on a zoomed out view. This will take a lot longer to get using the GeoJSON. So this data is being presented back from the server in GeoJSON. So it's now actually got the data, so the whirly things stop moving at the top, and we're displaying the 1 kilometer data. Now if we want, we can switch to binary. It makes getting the data a lot quicker and it's only applicable when you're looking at grid views. This only works with grids. So here we can see the same data, and what we're seeing here is we're actually stepping through the data. Now there are some discontinuities in this data which are odd, that this is seeing these sort of spokes, and these are emanating from the radar location. So we think that this is actual data issues, data quality issues in here. But anyway, so it's to improve the speed with which we're rendering and filtering and presenting this data, we have actually done an algorithm to select all the data on a row, and that means that when you zoom out, we get this slight difference, this slight poor graphics appearing, because we're actually striping this data instead of painting it as individual pixels. We're working it out as individual stripes, which makes it much faster to render, but does cause this slight pixelation of the data. So I'm just going to switch back into GeoJSON. So if we want to look at, actually I'm just going to go back into binary and just look at an API, because this is quite a lot of data. So if we're looking at an API for a 1 kilometer grid, this is on the 8th of January, the API for the whole region looked something like what it's going to do at the moment. So this sort of data, and again we can see this slight pixelation of this data becoming apparent. So this is the API. I'm going to move it back into 3 kilometer grids because I think that's sufficient for this data. So, and move it back into GeoJSON, and this would be daily rainfall as well. So again, that'll hopefully download a bit quicker. And that is the daily rainfall. So that's basically daily rainfall, showing all the values down here. So this should be in millimeters, not millimeters per hour. We have some issues with presentation of units on this. We're still just sorting out some of the little ironing out a few little features in it. So that's the grid type view. I'm just going to clear that using this tool. And we're just going to now move into multiple regions. I'm going to select a region, so I'm going to zoom in to, let's say the Peterborough area, and I'm going to draw a box around Peterborough. Now actually when we're doing this, we can actually use, if we're still in grid mode, we can actually just get the data for the individual. So this is now showing 1 kilometer grid data, but just for the grid that we're interested in. So if you're interested in seeing what's happening at a particular time, then in a particular area, then this is a much quicker way of displaying the data, the rainfall data. So let me just clear that again. Draw this box around here. Now we're going to go into Get Regions, touching Polygon, Get Regions. So this is now just getting the various polygons that we're associated, that we've got, or the regions that are assigned or located around this area. So these are the sort of catchments that we're getting. So they're relatively high detailed resolute regions. So there's quite a few points in them, so it takes quite a while to download it. So these, if we want to now, we can now go and start looking at getting other data. So if we want to get rainfall intensity data, this is now going to get the rainfall intensity for each of these regions. Now this is actually showing something which isn't displayed here, which it should be, is it's actually getting it for this particular time. So we're using this time to get the data. So this is at 1740, and if we change, that's 5 minutes, it would have changed slightly. So that's effectively giving us the rainfall intensity in each of these regions at that particular time, and we can look at selecting the API 30. So that's in millimeters of rain, so that should be millimeters, and we can get the rainfall return period as well. So that's doing a 1 in n years. Now the rainfall return period is quite a complex calculation, because effectively we can only calculate the rainfall return period once all the rainfall has finished at a particular time. So we're having, when it's operating in real-time mode, it actually keeps a cache of every single grid of rainfall, and it's processing these large numbers of grids. So actually it processes and calculates the rainfall return period once that the rainfall has stopped, and it's stopped for a set number of periods of time. So that effectively is working out the data for each of these individual regions. And we can now, if we look to choose a region, it changes to single region. We can now go and say, right, I want to now look at the rainfall return period, because we've now selected an individual region. We're now working within this time range. So now it'll get back a graph, so we can actually see now the rainfall return period across that date range. And if we want, we can increase this up, and we can use it, and we can get that, and we can actually start putting aggregation on here. So one of the aggregations we've got on multiple regions is we can work out maximum rainfall intensity periods. Now one of the things that we can do here is if we can click to show the parameters. So this is on the individual catchment. These are all the parameters that we actually can edit. So the area is calculated. That's just calculated from the coordinates which are being given for each of these catchments. We are working out some impermeable, some of these percentages. Some of these are just they're set as defaults. So the effective permeable percentage and impermeable percentage area, these are just these have just been set normally as default for each region. Flow high alarm is set to the same as the population, and the population is being driven from the area. So effectively, because we don't have all this data, we just made up some of these numbers. So effectively, but the point is that we can change these and we can customize them. So and then we've got other key issues: infiltration flow, initial loss, millimeters. And some of these variables at the bottom, these 4 variables at the bottom, aren't used at this particular moment. It's for if we wanted to use a different catchment model. The rainfall minimum period, intensity, and termination period is effectively dictating the period from after which we dictate when a rainfall event has finished, and therefore it's used in the calculation of the rainfall event period. And so that's effectively dictating it's going on for 6 periods, which is data's 5 minutes, so it's after 15 minutes of data where the rainfall intensity is less than 2 millimeters. That's what defines the end of a rain event. So if it meets those criteria, then that's the end of a rain event, and that's when we're calculating the rainfall event periods. But we can all of those can be adjusted and changed. I think that's near the conclusion. One thing actually I will just say, what we can do is we can create custom regions, which is an important attribute. So we can say, right, I want to create my own region just around Wisbeach. It could be a polygon or something or other. So I can now go and create a custom region. So this is now gone and created. This is a custom region in the database, and it's gone and got these settings. So it's worked out the area. These are the default values, 60, 60. It's worked out again, this population from the area, because we don't know it. So it's effectively worked out and set all these attributes for this particular custom region. And now we can go and within our custom region go and look at all of the data that we want to see. So we now should be able to go and look at my API 30. So that's my API 30 for this particular custom region. My dry weather flow, impermeable flow, etc. So the act of creating the custom region creates a temporary region within the database on the server. That database, that custom region, the calculations are immediately processed, and effectively it's been, so instead of having 6,000 regions, we now have 6,001 regions, except within about 15 minutes this custom region will be dropped. It is temporarily cached and temporarily created. And this is some of the core functionality that we got in developing the what if type capability of the service. So we can create, say, what if something happens, what if something else happens, and we can go and create new regions, process them, see what happens. They'll get deleted automatically. So I think that covers a very, very quick overview of the new Meniscus application analytics platform and the front end that we are displaying. Thanks for your time. Bye.